Hello everyone, this is LeetCode 733 Floodfill. So we have an image represented by an m by n integer grid image, where image ij represents the pixel value of the image. So we're given three inputs, SR, SC, and color, and we have to perform flood fill on the image from the starting pixel. The starting pixel is image SRSC. In this example, image SRSC would be this red cell here. Or I should just call it a pixel. This pixel right here would be the starting pixel. And basically, we have to check four directionally, left, right, up, down. Are those pixels the same color as the starting pixel? If they are, we need to replace them with our input color. And after that, we need to basically check all those four pixels and check them four directionally. And if they're the same color as that pixel that we're on, we change those to the actual color. And so we have to do it like that. Now that may be a little bit confusing. And by the way, after we're done with all that, we have to return the modified image. So that may be a little bit confusing. So I'm going to go through this example and explain it the best I can so it makes sense. Okay, now this red pixel, the colors are represented by the integers, okay? The only reason this is red is because it's supposed to show that this is a starting pixel. And the only reason these are blue is because it's supposed to show that these are the pixels that get changed, okay? That's all. The actual colors are represented by the integers, okay? So our starting pixel here is the integer 1. That's the color, right? So we check four directionally. Which ones are the same color as the starting pixel? Well, this one is because it's also a 1, and this one is because it's also 1. So this, and this all get changed to color, which would be 2. 2, 2, 2. So these would get changed to 2. Then we would check here four directionally. This one's already 2. We check here. Oh, this is the same color as the starting pixel, which would be 1. Oh, this is the same color as the starting pixel, which would be 1. So these would get changed to 2. This would get changed to 2. Then we would go here. This was already 2. This one should be already 2. Now we check here. Oh, this one's the same color as the starting pixel, so it get changed to 2. So these would all get changed to 2, right? Here, at this 0 and this 0, they wouldn't get changed to anything because they're not the same color as the starting pixel. Starting pixel is 1. These are 0, right? So this would never get changed. And this one here also would remain unchanged because, well, we can't really, it's isolated, right? So we would never reach it four directionally. Okay, I hope that makes sense, right? Me kind of saying that. And again, this example, I'm just going to reiterate this just so it's super clear to you. All the red is showing is that it's the starting pixel. All the blue is showing is that these are the pixels that are going to be changed. They don't represent the actual, quote unquote color in the image. The color is represented by the integers, okay? So just to make that clear, because if you're not aware or paying attention to that, it might be confusing, okay? So the color is represented by the image. Okay, so because this gets changed to 2, these two get changed to 2, right? Now when we're here and we have to check this against this one and against this one, if they're the same as the starting pixel, well, these already got changed, right? These three. So how do we know what the starting pixel is? We have to store it, right? So that we can access it later. And in terms, so because also we have to keep checking for each pixel that we change four directionally. That seems complicated, right? So we're gonna have to use a recursive approach to basically check the entire grid of depending on what we change, right? So we change this and we change this. Well, that means we have to check from here four directionally, from here four directionally. We change this, we change this. Well, we have to check from these four directionally. Then from here, we check four directionally. That's already done. Now we change this to 2. This gets changed also, so we have to check that four directionally. And so that's how we do that, okay? Hope that makes sense. I'm trying to explain it to the best I can using kind of the visual here. But yeah, I think like paying attention to the input here might be a little bit confusing. That's why I'm using the image a lot. And I hope it's super clear. It should be clear. I think I explained that pretty well. But of course you can ask any questions if you're lost. So again, we need to store the starting pixel, okay? And the starting pixel, remember, is just image srsc, okay? srsc, that's the starting pixel color. We also, when we get here and we're checking forward directionally, we need to make sure we're in bounds, right? So when we're here, we know there's not going to be anything here because it's out of bounds. So we need to actually make sure we store the height and the width of the grid, okay? So I'm going to say length of the image, that's going to be our height. Our width is going to be length of the image 0. Okay. And now we're going to make a function, and we're going to call this function recursively, to kind of check the adjacent pixels. When I say adjacent, I'm really talking forward directionally, obviously. And again, we're going left, right, up, down, okay? We don't go diagonal or anything, okay? It says right here in the description it's forward directionally. So we're going to need the SR and SC because SR and SC really is going to be where the current row and the current column are at, and we need to check that against the height and the width. We're also going to need the starting color to check if the current pixel we're on is equal to the starting color, or if it's already changed to color. And again, color in this example would just be 2. So we're going to need starting color, and then the current row and column we're at. Okay, so we're going to say if the current row we're on has to be less than or equal to the current row we're on has to be less than 0, and also, or sorry, the current row we're on has to be greater or equal to 0, and less than the height. Because we're using an index here, by the way, or rather when we do our calculations with the grid, we're using indexes. That's why we do less than check if SR is less than height, right? Instead of less than or equal to height, okay? Because really SR is going to be an index. And then we're going to check for the column. The column would be the width, okay? So we basically need to do, is it less than or equal to 0, or is it and make sure, or sorry, it has to be greater than or equal to 0 or less than the width, okay? And so SRSC is the current row and column we're at, meaning that whatever specific pixel we're at, that's why they're inputs. And we need to make sure that they're the same as the starting color, because if they're the same as the starting color, that means we're going to actually end up changing that specific pixel, right? Now, let's say we're on a pixel. Okay, so this gets changed to 1, and this gets changed to, sorry, this gets changed to 2, and this gets changed to 2 as well. Now, let's say we're here, right? Then this would get changed to 2, and this would get changed to 2. But we need to check forward directionally here to make sure this is not a 1 also, right? So let's say we go here. Okay, this already, above here, right here, this already got changed to a 2. So when we're checking forward directionally from this pixel, when we're comparing to this, we know that that's going to be equal to color, so we're not changing that, right? So we actually need to make sure that a specific pixel we're looking at is not equal to color. Because if it's equal to color, there's nothing to change, right? So it's already 2. right? If we're looking at at one of the neighboring pixels, if it's already 2, then we don't care about it. It's already changed to what the color we want. So we need to make sure it's not equal to color. So we're going to say image sr sc, and again, the only time we would enter this if statement is if we're in the grid. The specific pixel we're on is equal to the starting color, which would be 1. So like, let's just say pick a random pixel. Here, is this pixel equal to the starting color? Yes, because it's 1. And it's not equal to 2, which would be the color. Yes. So we would enter the if statement. What we would need to do in the if statement is change this specific pixel to a 2, right? Which would be color. So we're going to say image srsc, that's going to be equal to color, right? So it's going to get changed from starting color to color. So this specific pixel would be changed from 1 to 2. Okay. And by the way, when we first call this function, it's actually going to be starting on the starting pixel. So technically, the very first pixel that gets changed to a 2 is going to be a starting pixel. Okay. Because we're going to pass the coordinates of the starting pixel when we first call this function, fill. Okay. So technically, the very first pixel that gets changed is the starting pixel. It would be changed from starting color, or I guess we call it starting pixel, but really starting pixel is just the color, which would be 1. So that starting color pixel would get changed to color, which would be 2. So this would be changed from 1 to 2. Okay, and then we need to do it 4 directionally, check 4 directionally, and make sure that check if they're the same color as the starting pixel, which would be 1, and that 1 is stored right up here. And so to check 4 directionally, we would need to make some recursive calls, right? So in that side, the same if statement, because it got executed, we would make those recursive calls. So we'd say fill, and we would check the row above. Or sorry, we're on row, yeah. So we would check above and below. Okay, so let's check our input parameters. So SC would pass the same starting color, would pass the same color. SC, that's the same color. Do this just to make it a little bit quicker. Now we checked above and below. Now we need to check to the left and to the right. So that'd be the column, right? We would check to the left and we would check to the right. So these calls are working like this, right? We're checking the row, so it'd be here first, then here, then we check here, and then we check here. Okay? Yeah. And it's basically when it gets called recursively, we check the same if statement. Is it in bounds? Is the current pixel we're at the same color as the starting pixel? And is it not equal to the actual color? If all those are true, we enter and we change the starting pixel color to the actual color we want, which is our input, given to us in our input. And yeah, that's how we kind of handle this problem recursively, okay? Now we're going to say fill SR. By the way, sorry if you hear some noise outside. There's some snow trucks outside because there's like a blizzard here. So now outside of that function, we're going to say SRSC. We're going to pass it the starting pixel. By the way, I said starting color here. I'm sorry. It should be starting pixel. It really is the starting pixel's color. That's what starting pixel is. The reason I put starting color is actually I did this problem once before and I used a starting color. But I remember I changed it to starting pixel as a variable name. Anyways, this is our function call. Let me put this down a little bit just so you know that's not part of the actual function. Starting pixel, and we pass it the color. And we have to return the modified image, so we just return the entire grid. Okay. Yeah, return the modified image after performing the flood fill, so we just return the entire grid. And again, when we're calling the function the very first time, it's SRSC. That's given to us in our input, okay? We used it to calculate the starting pixel. SRSC at first as in our input, that's just the starting pixel's location, right? The row and the column of the starting pixel. So yeah, when this function first gets called, basically we check the starting pixel. Is it equal to the starting pixel's color, which is basically is the color equal to itself? It is. So we and make sure that it's also not equal to the color, which it wouldn't be because well, it'd be equal to 1, not 2. And so we would change this to 2, and then we would recursively would check above, below, to the left, to the right, and check if those are equal to the starting pixel's color. And if they are, we would change them, etc. Okay, so that's how this problem would be done recursively. Yeah. I know this video is a little bit long, but I just wanted to over-explain things just so it's a little bit clear, because I don't want to kind of rush through the video and you don't really learn anything about the problem. So that's why I went really slow. By the way, let me just click here really quick. I want to see what the hint is. Yeah, even the hint kind of points you to using recursion to check if the pixel is the correct color or not, and if it's use recursion to paint the pixel as to the correct color, and then recursively check the neighboring pixels. So yeah, it wouldn't tell you the hint would basically point you in the right direction by telling you to use recursion to paint the pixels. But yeah, sorry for this video being a little bit longer than usual, but I just wanted to make sure I understood and explain everything well, especially the image, just so you're not confused by that. But I hope this video helped you, and I'll see you in the next one.